We're all trying to switch to clean energy, right? But there's this huge, fundamental challenge holding us back. Today, we're going to look at how a really clever new type of artificial intelligence is helping us crack the code for a reliable green energy grid. So let's just start with this one big question. What if we could get clean energy from the sun and the wind that was just as dependable as the fossil fuels we're trying so hard to replace? I mean, that's the dream, right? But there's a very real paradox standing in our way. All right, so let's really get into what this paradox is all about. We all want clean energy, but it comes with this tricky built-in challenge that we absolutely have to solve if we're going to make this work on a global scale. So here's part one of the equation. Solar power is amazing. We get this massive surge of energy right in the middle of the day, peaking around 1 p.m. when the sun is directly overhead. It's powerful, it's predictable, as long as the sun is out. And then, here's the other side of that coin. This graph shows when we actually use the most energy. And look at that huge spike in the evening, around 9 or 10 p.m. That's when we're all home from work, cooking dinner, turning on the lights, watching TV. And of course, that's hours after the sun has set and our solar production has dropped to basically zero. This gap, this mismatch, is the heart of the problem. And this whole problem, it has a name: intermittency. It's just the simple, kind of frustrating fact that renewable sources depend on the weather. If you rely only on solar, you're betting against clouds. If you rely only on wind, you're betting against a calm day. But what if we didn't have to gamble? What if we could engineer our way out of this? Let's take a look at how we can build a much more reliable system by thinking about our energy sources in a whole new way. The big idea here is something called a hybrid renewable energy system, or HRES. Instead of putting all your eggs in one basket, you build an energy dream team. You combine solar and wind so that hopefully, when the sun goes down, the wind is picking up. It's all about having one source's strengths cover for the other's weaknesses. Okay, so just combine sources, problem solved. Simple enough, right? Well, not quite. It turns out, when you solve one problem, you create this insanely complex new one. It's like trying to solve a puzzle with a billion pieces. Because you can't just, plop down some solar panels and wind turbines and call it a day. To get a system that's actually reliable and super efficient, you have to answer some incredibly difficult questions, and the stakes are really high. I mean, just think about it for a second. For every single hour of the entire year, you have to find the absolute perfect mix. How many solar panels? What's the exact tilt angle for them? How many wind turbines? What's their specific installation height? Every single one of these variables affects all the others, and it creates this massive optimization puzzle that is way, way too complex for any human to figure out on their own. And this is where things get really cool. This is where AI steps in. A team of researchers in Portugal developed a brand new AI algorithm that was literally designed to solve this exact type of enormous multivariable puzzle. Now, what makes this AI so special is that it's actually two AIs working together rolled into one super algorithm. Think of it like a treasure hunting team. On one side, you've got the Gray Wolf Optimizer, or GWO. It's the explorer, scanning the entire map to find all the promising areas. Then you have the Particle Swarm Optimizer, or PSO. That's your expert miner. It comes in and digs deep, super efficiently, in the spots the explorer found to pull out the actual gold. And this flowchart here is basically their game plan. You can see how they work in tandem. The GWO explores really broadly, so it doesn't get stuck on a bad idea, and then it hands off its best leads to the PSO, which then refines the solution with incredible speed and precision. They pass information back and forth, constantly improving to find the best answer way faster than either could on its own. So the theory is solid, the AI sounds brilliant, but does it actually work in the real world? To find out, the researchers threw a massive data set of real weather patterns and energy demand from Portugal at it. Let's see what happened. In the first run, the AI showed some promise. It found some decent solutions, but its performance was a little shaky. It got what's called a fitness score, where a lower number is better, of around 0.4. This basically showed that the AI was in the right ballpark, but it couldn't consistently lock in the absolute best answer. So for round two, the researchers tweaked the AI's settings, hoping to dial it in. But in a classic scientific twist, things actually got worse. The fitness score went up to 0.455. Now, this might sound like a failure, but it was actually a super important clue. It showed the algorithm was getting stuck in a dead end and couldn't find its way out. So for the third try, they decided to go big. First, they expanded the range of possible solutions, just giving the AI a much bigger playground to search in. And then they gave it more processing power and more time to really think through the problem. And the result? A total breakthrough. The third experiment started with a fitness score of 0.150. I mean, that's already far, far better than where the other experiments even finished. And from there, the score only got better, which proved the AI had finally learned how to navigate this maze and find a truly optimal solution. So the crucial point here is that this wasn't about failure. It was a learning process. Through trial and error, this hybrid AI figured out how to solve this incredibly complicated energy puzzle and do it efficiently. It literally got smarter with each attempt. So what does one successful experiment in Portugal mean for the rest of us? Well, it's about something much, much bigger than just one grid. It's really about a new blueprint for our entire energy future. As the researchers themselves point out, this isn't just about this one algorithm. It's about a whole new way of thinking. By combining different AI tools, you can create systems where they complement each other, letting us solve problems that were once considered just too complex for humans or even a single AI to handle. And what you should really take away from this is that we now have a powerful new partner in this quest for sustainable energy. This AI approach gives engineers a blueprint they can use to design the best possible clean energy grid for any location on Earth, whether it's for a tiny village or an entire country. Which leaves us with a final and pretty hopeful thought. The biggest barrier to reliable clean energy wasn't just about building more panels or turbines. It was a massive optimization problem. And now, with AI as our partner, we have a revolutionary new tool to solve it. The technology is here, and it's getting smarter every single day. So the only question left is, how fast can we build that clean energy world?